So now we will discuss about EIGRP metric calculations. EIGRP metric calculations. EIGRP has 5 metrics. There are total 5 metrics. So EIGRP has 5 metric components: bandwidth, delay, reliability, load, and MTU. These are the EIGRP metrics. But EIGRP use only bandwidth and delay. It does not consider reliability, load, and MTU. By default, EIGRP use these two. So here there are some default bandwidth delay. So these default bandwidth and delay depends on interface type. For fast Ethernet, the default bandwidth is 1 lakh kilobits, 100 Mbps. For serial interface, the default bandwidth is 1544 kilobits. Delay 100 microseconds for fast Ethernet, 20,000 microseconds for serial interface. Reliability is same for both interfaces. Load is also same for both interfaces. MTU is also same for both interfaces. Here one important point is here, EIGRP use lowest bandwidth along path and total delay along path. Lowest bandwidth, not cumulative bandwidth, lowest bandwidth along path. Lowest bandwidth means, see here, we have one topology. Here we have 3 routers, R1, R2, R3. Between R1 and R2, I have taken serial connection. But actually we are not using serial connection nowadays, but just for understanding purpose I have taken here serial connection. And between R2 and R3, Ethernet connection, fast Ethernet. For serial connection, these are the default. Bandwidth is 1544 kilobits and the delay is 20,000 microseconds and reliability is 255, load is 1 and MT is 255, MT is 1500 bytes. For fast Ethernet, bandwidth is 100 Mbps, delay is 100 microseconds, reliability is 255, load is 1 and MT 1500 bytes. From R1 to reach 192.1.2.0 network, from R1 to reach 192.1.2.0 network. So R1 consider bandwidth, lowest bandwidth along path. Along path means here, between R1 and R2, the bandwidth is 1544. Between R2 and R3, the default bandwidth is 100 Mbps. But here what is the lowest bandwidth? Lowest bandwidth is 1544 Mbps. So R1 consider the bandwidth for 192.1.2.0 network 1544 Mbps only. It does not consider 100 Mbps. It is lowest bandwidth along path. But R1 use total delay. Here see, from R1 to reach this network 2.0 network, between R1 and R2 delay is 20,000 microseconds. Between R2 and R3 delay is 100 microseconds, means 20,000 plus 100 plus this LAN also 100, right? Total 20,200. So R1 from R1 to reach 192.1.2.0 network, bandwidth is 1544 kilobits and delay is 20,200 microseconds. These are the metrics to reach 192.1.2.0 network. So this is the minimum bandwidth. This is total delay. Here I will show you this. Okay, first I will configure these interfaces R1, R2, R3, and then we will see this bandwidth, delay, everything. Okay. So configuration is R1, enable, configure terminal. Hostname is R1, interface F0 by 0, IP address 192.168.1.1.255.255.255.0. No shutdown. Exit. Interface serial 0 by 0. IP address 12.0.0.1 255.255.255.0. No shutdown. Exit. Now configure EIGRP. Router EIGRP1. You can use any number. This is the autonomous system number. This autonomous system number can be any number between 1 and 65,535, and we should use the same AS number between these three routers. Okay, router EIGRP1, network 12.0.0.0.0 and network 192.168.1.0, and no auto summary. So we will discuss what is the purpose of this command, okay, later. Okay, this is the EIGRP configuration. Now R2 host name is R2, and serial 0 by 0, IP address 12.0.0.0.2, and fast Ethernet 0 by 1, IP address is 13.0.0.0.2, and here network 13.0.0.0.0. And next R3. R3 192.1.2.1 is a LAN network, and for F0 by 1 13.0.0.0.0.1 13.0.0.0.0.1 and 192.1.2.0. This is R3 configuration. Copy, paste in R3. Okay. Now see, first verify the routing table in R1. Here, show IP route, EIGRP. See here, 192.168.2.0 network has received from 12.0.0.2. 12.0.0.2 is R2 IP address. This is routing table. But if you see topology table here, show IP EIGRP topology. 192.168.2.0 network received from 12.0.0.2. So here there is one bracket. The first value is feasible distance. The second value is advertised distance. Feasible distance and advertised distance. Feasible distance is total metric from R1 to 192.2.0 network. This is the total metric. This is called composite metric. This is advertised distance. Second value is advertised distance. This is R2 from R2 R2 metric. Simply say 3072 is neighbor feasible distance. This is the feasible distance from 12.0002. Simple. Now, if we see details here, 192.1.2.0, show IP, EIGRP topology and network. See, minimum bandwidth, total delay. Minimum bandwidth is 1544 kilobits. Total delay is 20,200 microseconds. See here, composite metric. By default, EIGRP use minimum bandwidth and total delay. EIGRP does not consider this. See here, it is also showing hop counts. From R1 to reach 192.1.2.0 network, there are 2 hops, but it does not consider in metric calculation. Okay, just leave it here. But it supports 100 hop counts by default, maximum 250 per. But it is not considered in the metric calculations. When it is selecting metric, okay, this is the metric, right? But composite metric is nothing but just only these 2. See here 3072. 3072 is actually from R1, it is advertised distance. But simply say it is a feasible distance of 12.0002. If you see R2 routing table, or topology table, any table, show IP route, EIGRP, see here. From here to reach 192.2.0, what is the metric here? 3072. This is the feasible distance. But now we understand how this value came. This value, composite metric. How this composite metric came. So here there is a formula. The formula is one second. The formula is this one. EIGRP metric formula 10 to the power of 7 by minimum bandwidth plus total delay by 10 and 256. See here 10 to the power of 7. See here what is showing here in topology table. What are the metrics in topology table? R1 topology table. So these are the metrics, right? Minimum bandwidth, this one. Okay, I will copy this. See here. Yeah, see minimum bandwidth 1544. So 10 to the power of 7. 10 to the power of 7 means after 7 zeros. 1, 2, 3, 4, 5, 6, 7 by minimum bandwidth. Minimum bandwidth is 1544 plus total delay. What is the total delay? Here, see here 20,200. 20,200 by 10 into 256. So okay, now open calculator. 1 to the power of 7, right? 1, 2, 3, 4, 5, 6, 7. After 7 zeros by 1544. What is the value? 6476. 6476 plus 20,200 by 10. 20,200 by 10. 20,200 by 10. 2020. 2020 into 256. Now here copy and see 2174976. If we see here value 2174976 exact value. This is how EIGRP calculate metric. How EIGRP calculate metric. I will explain one more time. See here, very simple. Actually see here what happened. 192.168.2.0 network is directly connected to R3. Is directly connected to R3. So 192.168.2.0 network is connected to fast Ethernet 0x0 on R3. So from R3 to reach this LAN, right? It is a directly connected LAN, right? So from R3 to reach this LAN, these are the metrics. Bandwidth is 100 Mbps, delay is 100 microseconds, reliability is 255, load is 1, MT is 1500, and hop count also is there. Hop count is 0. Hop count is 0. See here, I will show you this metrics in topology table. Show IP EIGRP topology 192.168.2.0. See, it is directly connected network. See here, it learn from connected. Neighbor is 0, 0, 0, own network, local network. But see here, composite metric. It's showing only feasible distance. It is not showing any advertised distance. 28160. But what are the minimum? What is minimum bandwidth? What is the delay? What is reliability? What is load and MTU? Minimum bandwidth is 100 Mbps and the delay is 100 microseconds. Now, if you calculate this bandwidth and delay, so 10 to the power of 7 by here, right, 1 lakh, right? So 1 lakh means, see here, from R3 to reach 190, okay, to reach 192.1.2.0/24. It is a local network, right? 10 to the power of 7 means 1 after 1 7 zeros, 1 2 3 4 5 6 7 by 1 lakh. 1 lakh means after 1 7 5 zeros plus total delay. Total delay is 100 microseconds by 10 into 256. Now see here, 10 to the power of 7 by 1 lakh. What is the value? Value is 100. Just minus 5 zeros here. Here 5 zeros, here also 5 zeros. Okay, minus 5 zeros. Okay, 100 plus 100 by 10, 10 into 256. Total 110 into 256. See, 110 into 256. Here 110 into 256. See, 28160. So from R3 to reach this network, what is the composite metric? Composite metric is 28160. Okay, and now what happened? R3 will advertise this network 192.168.2.0 network to R2. R3 will advertise this network to router 2, but it will advertise not only network, it will also advertise these values: bandwidth, delay, reliability, load, MTU, and hop count. So R3 will advertise these all settings. So what are the settings? Network is what? Network is 192.168.2.0/24, and bandwidth is what? Bandwidth is 100 Mbps, and delay 100 microseconds. Okay, these two. Okay, remaining are common. Okay, remaining are same, but don't okay, just leave it remaining. And R3 will advertise this network with these values: bandwidth, reliability, load, MTU, everything. Okay, right? Advertise to R2. But when R2 receive this update from R3, R2 will compare bandwidth with receiving interface bandwidth. What is the receiving interface here? Receiving interface is F0 by 0. For F0 by 0, what is the bandwidth? 100 Mbps. Same. So in the update packet, what is the bandwidth? 100 Mbps. So same. It will consider only 100. But what is the delay in receiving interface? The delay is 100. But what is the delay in update packet? 100 here. See here also showing 100. 100 plus 100 to 200. Right? So now see here. If we see R2 topology table, show IP EIGRP topology. 192.168.2.0. See, minimum bandwidth is 100 Mbps, but delay is what? Total delay is 200. Just don't think about this for 100 Mbps and delay 200. Now see here. What is the composite metric? Composite metric is 30720. Allowed distance is 28160. So 28160 is feasible distance of rotor 3. 3072 is what? Feasible distance of R2. Now see how this value came 3072 here. Same, right? So the calculation is what? 10 to the power 7 by 1 lakh means 100 plus here what? 200 by. So 1 second. Here I will write, okay? From R2. Okay. From R2. Network 192.168.2.0. Here what? 200. Now see. 100, 200 by 10, 20. Now 120 into 256. See, 30720. 30720. See, 30720. Again, what happened? R2 will advertise 192.1.2.0 network to R1 with bandwidth. So again, R2 will advertise network 192.168.2.0/24. Bandwidth is 100 Mbps. Delay is 200. Delay is 200. When R1 receive this update, R1 will compare bandwidth with this interface. For serial 0 by 0 interface, the bandwidth is 1544 kilobits, means 1.5 Mbps. But in update packet, what is the bandwidth? 1 lakh kilobits, means 100 Mbps, which is the least one. 1.544 Mbps is the least one. So R1 will take that metric as a that metric. R1 will not consider 100 Mbps to reach this LAN 192.2.0. And delay. What is the delay of serial this interface? 20,000. And what is the delay in update packet? 200. 20,000 plus 200. 20,200. Now see here. R1 topology table. Show IP EIGRP topology 192.168.2.0. See 1.44. It's showing. And delay is 2200. Plus the composite metric is 217496. We already calculated this value. Right? So this is how EIGRP calculate metrics. So here remember point, okay, bandwidth. So bandwidth is compared with the receiving interface. And delay is added to received delay. Remember these 2 points. Okay, so this is the how EIGRP calculate metric. Okay.